next topic is Hooke's law and stress strain diagram. Now the basic law we can define now. What is the statement of Hooke's law? This was given by Robert Hooke in the year 1679. What is the statement of Hooke's law means? The stress is directly proportional to strain within the elastic limit. Here the stress is directly proportional to strain. Now we just remove the proportionality constant. We can introduce the constant. The constant is called as a E. That is constant is called as a elastic constant or elastic modulus. Now if we observe the stress strain diagram, here the different points we have indicated in the curve. Here O, P, Q, R, X and S. Here the OP indicates. Here the OP portion indicates starting from here to here. The OP portion indicates it is a linearity where the stress is directly proportional to strain in this portion. That is called as a linearity. This is the only region where the Hooke's law should be valid because the statement it will states that stress is directly proportional to strain. Now between P and Q, in between we can define the body continues to exhibit perfectly plastic or perfectly elastic. Now the body continuously exhibit perfectly elastic up to the point Q. The curve will be retraced if the applied force is removed at any point between P and Q. However, the linear dependence between stress and strain is not observed in this portion. Only from O to P we will observe stress is directly proportional to strain. But P to Q, up to the Q, there is a elastic nature, but we can't observe in this portion there is a linear dependence between stress and strain. Now the portion P and Q is called as a proportionality limit, or that is called as a elastic limit. Now by knowing the elastic limit of the material, one can find the maximum deforming force that can be given by the body can be subjected to undergoing without any permanent deformation. Now here the deformation is coming. Already we know that what is a deforming force. Now can I repeat once again? What is a deforming force? Is the force that can be produced a change in either shape or size, or it may be the both. It can be given by the Q, that is called as a yield point. This Q what and all we are giving, that is called as a yield point. At the point between Q and S, here we have shown as a Q and S. The body fails to regain its original length by applying the force. That is called as a perfectly plastic. Here we have shown as a perfectly plastic. There are two types of plasticity. One is perfectly elastic, another one is a perfectly plastic. Already we have defined here elastic nature. Now here it will be exhibiting as a plastic nature. By knowing the deforming force, when it won't come back to the normal shape, that is called as a plastic behavior. That is called as a permanent set. We can define as a, that is called as a permanent set. The deformation because large enough to pull the molecules far apart that the binding force breaks beyond S. Here X we have written. Beyond the S, the body can be fracture point. We can define the body can be fracture point because the body will be no more. The force per unit area in which the wire breaks is called as a breaking stress or fracture point. Between Q and S, see here between Q and S, in between we have defined as a X. Now what is the X? Here in that X, the body can be in a strain hardening and strain softening. Between Q to X, the body is in the strain hardening. Between X to S, the body is in the strain softening. Between Q and S, it is the plastic range. This is the subdivided into two regions named as strain hardening and strain softening, and the peak point on the curve. This is the peak point on the curve.